to the JUMP software just to kind of show you what happens when that success failure condition is not met. So here I've got a population proportion that's 20%. This is just saying like blue is what we're looking at, like heads or tails, blue or green or yellow or whatever. So we're just examining, this is a success, a blue M&M. Let's say there's 20% blue M&Ms. I'm going to put my sample size at 100. So NP would be 100 times 0.2, which is 20. And NQ would be 80. So we would expect 20 blue and 80 not blue, which are both greater than 10. So we would expect this to turn out to be a normal model. I'm going to skip all the way up to 100,000 samples at one time. So I'm not going to click on each individual sample. And boom. Looks pretty much like a normal model, centered at the population proportion of 0.2, and then our standard deviation is square root of PQ over N. But what would happen if I changed my sample size to 10 instead of to 100? Now, 20% of 10 is only 2, or 2 blues, which is not bigger than 10. And my failures would only be 8, which is not bigger than 10. So this sample size technically would be a violation of the condition. And let's go ahead and see what happens when I run these 10,000 samples. You can clearly see a slightly skewed right distribution, not a pretty normal model like we had when this sample size was 100. So as I increase the sample size, say from 10, let's do 20. You can start, still a little bit skewed right, but you can start to see as I get closer to it being big enough, it's starting to look more and more like a normal model. Now the number 10, where you need at least 10 successes and failures, is a little bit of a conservative estimate. Like this looks fairly normal here. But 20% of 40 is only 8, so I'm not even at 10 yet, and it already looks good. 10 is a fairly conservative estimate, but it is the condition that we use. We would want at least 10 successes and failures before using that normal model. So as I increase and get closer to where I would expect 10 successes and failures, I am getting a more and more normal. Ooh, that one was just unlucky. He kind of got way off. We just happened to have sample proportions that were a little off. But we would just go ahead and assume that as we get closer and closer to the 10 successes and failures, we would get closer and closer to what would be a normal model. Getting some funky sampling distributions there, but that's okay. Remember, it's infinite number of samples. I'm only doing 10,000. So technically, if I were to do another 10,000, it gets closer and closer to the normal model.